This is a video about an assignment that we got to do for Introduction to Engineering at Oklahoma State University, where we had to design a bottle rocket from paper supplies, where we had to use the engineering design cycle. Research.
What does research mean to you?
Research is having a measurement of an idea, a hypothesis that tends to have a mathematical model.
Research is about investigating and interpreting the given scenario of the problem that you have been tasked with. So for our rocket, we decided to investigate three things, which was a way to stabilize the flight, for which we found links to making fins, and another way to do it was to make it slow down in the air so that the crash impact wasn't as strong. So we decided to do research about parachutes. And then another thing we wanted to do is that when it actually did hit the ground, for it to not hit as hard, so we were investigating about crash barriers. Modeling.
What is modeling to you?
Where you take a design and you build a small version of it. Thank you, good night.
Modeling is about making a possible solution to the problem you've been given. For our bottle rocket, we had to design something that would crash very softly without impeding the flight, and we had to do it with office supplies, so such as vanilla folders, hangers, popsicle sticks, 2-liter bottles, plastic bags, and painter's tape. Implementing.
What does implementing mean to you?
I think it means building a project.
So this is making the spring out of a hanger. This is making the parachute out of popsicle sticks and paper bags. This here is taping down the fins with vanilla folders, and that was implementing. Measuring and testing.
Testing means to you?
I think testing is seeing if your project works or not.
Communication. Okay, what's communicating to you?
Communicating to me is like talking, and you have an idea and you express it to another person.
There are many ways to communicate results. The one that we're choosing to do right now is a YouTube video communicating all our findings and how we did the stuff, and basically we are very proud of our rocket because it did everything that we expected of it, such as flying high, maintaining stability, falling straight down, going straight up. Also, the parachute deployed, which is very good just by itself, seeing other teams and other things that happened. It slowed down the flight. What really caught our attention was the fact that it kind of floats down, which is really good. And finally, when it hits the ground, you can actually see the spring catching and doing its part in the work too. So, for example, if you would get to see the graphs that we had done, well, it also shows that our trajectory was a lot smoother and took more time to fall down to the ground. So we would consider it completely successful, and we're very happy with the results, and we would like anybody who wanted to repeat our experiment and have a great time. Thank you.